So example 1, we got a circle, and I'm just going to go and tell you right now, example 1 and example 2, I purposefully made these the exact same circles with the same measurement, so just keep that in mind when we get started. But example 1, part A says what is the circumference, part B says what is the arc length, so from here to there. But so the circumference is, again, it's like the perimeter of the circle. It's the distance all the way around the edge of the circle. And that formula, if you go back to the notes, excuse me, is 2 pi times my radius. We're going to leave pi as it is. So you can just treat that like an x, right? It's just a constant. It's going to we're just gonna leave that put right there. So when you have 2 pi r, you can just multiply the 2 and the r using properties of multiplication. You know, so 2 pi r is the same thing as 2r pi or pi 2r or pi r2. It doesn't matter how you rewrite this. So we can, in our minds, rewrite this as r times 2 times pi. So that's going to be equal to, so 2 pi r is 2 times my radius. R is my radius, that's 13 inches. My radius is 13, so 2 pi times my radius 13. And that's going to equal 2 times 13 is 26, so my circumference is 26 pi, and then I'm just going to put my inches. Okay, so guys, from here on out, anytime we see pi, we're just going to leave it in there. So 26 pi inches is my circumference. It's not saying it's wrong if you did 26 times pi and wrote that, so 26 times 3.14, whatever pi is. That wouldn't be wrong, and I would not count against it, but let's try to get in the habit of leaving pi in our answer. So what's the arc length? Well, remember, arc length is going to be theta, which is that little Pokeball thing, theta over 360 times, and now it's just going to be times my circumference, times 2 pi r. Well, we already found the circumference, 2 pi r, so that's 26 pi, so we can just kind of plug this in for that. We found our circumference already. So theta over 360, so 360 again comes from the entire circle is 360. So pretty much what we did, like when we found the circumference 2 pi r, we found the circumference of the whole. It's like we found the arc length of the full circle. So we did basically 360 over 360 times 2 pi r. Well, 360 over 360 is 1. That's why you don't see anything here. We're just finding a portion of the circle, so we're just finding 45 degrees worth of the full 360. That comes from right there. So that's why we got to do 45 over 360 times, and then 2 pi r. Well, we did that up here. This is 2 pi r, 26. So 2 times my r is 13 times 26 pi. And I do not have, I don't have a good calculator, so it's kind of weird. Yeah, well, no, I do have one, but I don't have any batteries for it, so we can't really do a whole lot with that. 45 divided by 360 is 0.125, and then 0.12, so this is 0.125 times 26 pi. So basically we're just going to do 0.125 times 26. And that's going to leave us with 3.25. And then we're just going to bring our pi out front. Or I guess not out front, but trailing inches. So the circumference is just 2 pi r, so 2 pi 13, that's 2 times 13, 26 pi inches. The arc length is going to be that same thing, but just times this over 360. So 45 over 360 times 2 pi r gets me this arc length right here. Okay, let's, I can't upload videos, I think, longer than 15 minutes. So let me make sure this is gonna stay within that time frame. I don't know. Oh, there we go. Yeah, we're good. Okay, let's run through example 2. I'm going to try to get this in one video. So example 2. These are the same circles, okay? So just keep that in mind. What is the measure of the major arc? So when I say what is the measure of an arc, that's going to be in degrees. If I say arc length, if you see the word length anywhere, that's going to be centimeters, feet, inches. If I just say what's the measure of the arc, that is in degrees. So what's the measure of the major arc? Well, the minor arc is equal to the central angle. So the minor arc right here is 45 degrees. But what's the measure of, so this is 45 degrees. So what's the measure of the major arc? So like going the long way around, well, we know that a circle has 360 total degrees of rotation. And then to account for the major arc, we need to just subtract off this 45 degrees, because this is what we're concerned with. We're concerned with what is the measure of this arc. Well, if this arc is 45 and the full circle is 360, to get the major arc, we have to do 360 minus 45 degrees, and that is equal to 315 degrees. So the measure of the major arc going the long way around the circle is 315 degrees. This arc is 45 degrees because the central angle is 45. The major arc is going to be 315. So 45 plus the 315 will give us the 360, which is what we need to check our, make sure that the circle is still a circle. Okay, so what is the length of the major arc? So its length, so we're going to do the arc length formula. Well, it's going to be theta over 360 times the circumference, which is 2 pi r, which is 26 pi, 2 times 13. Well, up here, we found this arc length. We found the minor arc length. Here, we're trying to find the major arc length. Well, the major arc has a measure of 315 degrees, so it's going to be 315 divided by 360 times 2 times pi times the radius. Okay? 315 divided by 360 is, here I'm going to write this little arrow. So 0.875 times 26 pi, 2 pi r, 2 times 13 is 26, and then I just carry the pi over. So 0.875 times 26 is equal to 22.75. So this is going to equal, let me make sure it's in frame, 22, it is, 22.75 pi. And then that's inches. So for number 1, we were just concerned with this minor arc, which was 45 degrees. Well, if this is 45 degrees, we understand that the major arc is just going to be 360 minus that, 315. So then this arc length, the major arc length, is just going to be 315 over 360 times 2 pi r.